Hello all. In this session, we will see one more problem in the friction. The question is, a small block of 1000 Newton is placed on a 30-degree inclined plane with coefficient of friction 0.25 as shown in the figure. Determine the horizontal force to be applied for. So here we have two conditions, that is the impending motion down the plane and the impending motion up the plane. So you have two conditions here. Figure you can see the ground level is little bit tilted, that is 30-degree it is tilted. Above that we have a one block and given horizontal force. Okay, so our ground level is tilted for 30-degree in this problem. So you have two conditions we have. Before going to the problem, we need to analyze the forces, which are the forces acting on the block and which are the forces developing on the block, that we need to see. So 1000 Newton is placed on the 30-degree, that is, so for the self weight, the self weight of the block is 1000 Newton. So because of the 1000 Newton, the reaction will develop, that is R. So the reaction, what is reaction, already we have studied in the last previous classes. So according every reaction there will be equal and opposite reaction. So because of the self weight, the one reaction is developing here. Next, because of the, if you are selecting first condition, that is impending motion down the plane, that means the block is coming downwards. So if the block is moving downwards, then the friction will be acting upwards. So the friction will be acting upwards, right? So for example, if you're taking the second condition, the impending motion up the plane, if your block is moving upwards, so definitely friction will be downwards. So this is the way we have to analyze the forces before going to the problem. So here the coefficient of friction, that is F is equal to mu divided by R. The coefficient of friction mu, that is already given, that is this will be already given, that is 0.25. So while taking F, so we need to take 0.25 into R. Okay, while taking the coefficient, we need to multiply it with the reaction. Okay, right. Okay, first we will select the first condition, that is impending motion down the plane. Here you can see the forces which I marked in the red color. So those are the forces we need to mark before going to the problem. Okay, so that is here, before going to the problem we need to mark that. See here, frictional force I have marked, reaction I have marked according to the condition, that is impending motion down the plane. But what about the angles? So angle plays a very important role here. That is, according to the problem, they have given 30-degree, this one. So exactly alternate angle 30-degree it will be. But here 60-degree will be with respect to the y-axis. Okay, so because this, according to the inclined plane, this will be 30-degree. So according to the normal plane, see this ground level and that line will be same 30-degree. So if the 30-degree is removed, if the 30-degree is removed, the remaining this will be 60-degree. Okay, so this is a way of taking the angle when the ground level is tilted for any angle, that is 30 or 60-degree, any angle. So this is a way of taking the angles. Okay, the impending motion down the plane. First one, resolving the forces vertically, that is summation of Fy is equal to 0. So we have to take all the vertical forces now. Okay, we will take all the vertical forces one by one. Here F is there, right? So that F vertical means it will be coming downwards. So that is minus F sine 30-degree. Next, this one, that is minus 1000 sine 60-degree. Next, this one plus r1 going upwards. So these are the vertical forces we have here. Okay, so if you substitute this minus f sine 30 degree means 0.5 minus 1000 sine 60, it is 866.02 plus r1 is equal to 0. Okay, so r1, if you shift this side everything, so minus will become plus, that is f into 0.5 plus 866.02. So this will be equation number 1. So it is nothing but you got a r1. See, we got r1 value. Okay. Okay, next, resolving the forces horizontally. Now we will see all the horizontal forces. Okay, first one, see here, this f. If you resolve that f, it will be going rightwards. So that will be f cos 30 degree. So f cos 30 degree directly I'm just taking with all the substitution. Next, minus 500, that is minus, that is 1000. Here you can see this. If you resolve this, it will be coming leftwards. So that is directly I'm taking 500 plus multiplied with 0.25 into f sine 30 degree plus 1000 sine 60 degree. So as I told, this I'm directly taking here friction. So this is called plus f. So here plus f, I'm directly taking the r1 value. So what is the r1 value? So directly I'm taking the same. Okay, so this one r1 value I'm directly taking. So if you substitute that, 0.86 f minus 500 plus, please multiply this, that is 0.25 into this and 0.25 into this. So we will get 0.125 f plus 216.505 is equal to 0. So collect all the this one and this one. So it will be how much? Okay, sorry, this one and this and this and this. So 0.985 f minus 283.495 is equal to 0. Okay, so f is equal to 283.495. if you shift this downwards, 0.985. so if you substitute this, we will get the f value, the force which is given force, that is horizontal force, will be 286.06 Newton. Okay, so this is the way of solving this problem. Next we will see impending motion up the plane. So as per the condition, first one is over, the second one is impending motion up the plane. Okay, thank you.